Hey, seventh graders, how are you? Happy Monday. Hopefully you guys all watched the video that I recorded about just like kind of catching up on stuff and making sure that you finish off this week and next week really strong. If you are missing any work, I will have posted in today's stream or actually in your classroom individual assignments. So make sure you're looking out for that just in case you are missing stuff, and also obviously check RedWeb as well. Okay. Today we're going to continue with our probability and we're going to talk about sample spaces. And when we talk about sample spaces, we use some certain counting methods. So to come up with the first kind of definition, if you will, we're looking at something called sample spaces, and all the different outcomes of an experiment are going to make up a sample space. So we have an example here. When you have a die, you have the numbers 1, 2, 3, 4, and 5 on a number cube. Therefore, there are 6 different possible outcomes. Okay, like I said, all those outcomes are going to be the sample space. There's a couple ways that we can show this out, and to quote, show your work, so to speak. There's a couple different methods I'm going to show you, and then I'm going to show you the counting method. So don't write all this down when you're taking your notes. Just take down the key words. So this is saying one bag has a red tile, a blue tile, and a green tile. So that's one bag. And then another bag has a red tile and a blue tile. Vincent is going to draw one tile from each bag. What are the possible outcomes? We want all of the possible outcomes. And how many outcomes are there in the sample space? Okay, so, excuse me, to understand the problem, you're basically trying to figure out important stuff. Again, I don't want you to write all this down, but the important stuff is there are 2 bags. One bag has red, blue, and green tile, and the other bag has red and blue. Now, if you're writing down the keywords from a word problem, you already have the important stuff down. Okay, this is just kind of breaking it down for you. Okay, what we can do is make a list to show all the different outcomes. Okay, so if we do that and we record red as R, blue as B, and green as G, obviously. If we record all the different outcomes, if we pull a red from bag 1, we can either pull a red from bag 2 or a blue from bag 2. So if I pull red first and then I do another pull, I might have an option of getting another red tile. If I pull red first from the first bag, I might have an option of getting a blue tile next. Okay, then in bag 1, we also have blues and we have greens. Okay, so if I pull a blue, I might have a red or I might have another blue. And then finally, if I pull a green, one option could be green red, the other could be green blue. Okay, so if you count up all the different options, 1, 2, 3, 4, 5, 6, we have 6 different outcomes in our sample space. Okay, I'm going to show you a way to do this in a minute, but I kind of want you to see how we come to learning how to do that easy part. Okay, and if we look back, that was just kind of to check your work, but when you write out those charts like that, you've pretty much checked your work as it goes. Okay, now the other way we can do this is to use a tree diagram. So if we have 4 cards and 2 tiles in a board game, I want to find all the different outcomes I might have. The cards are labeled north, south, east, and west, and the tiles are labeled 1 and 2. So you're going to normally pick 1 card and 1 tile. And so with that, we're trying to find out the different outcomes. If we make a tree diagram, what you want to do is to start off by listing the letters of the cards. So we have north, south, east, and west, correct? Yep. Okay. Now you also have 2 tiles, tiles 1 and 2. So if we do this and we list out north, south, east, and west, those are my cards. Okay, it's similar to the tiles, but now we have cards and a tile. So if I take a north tile and then I pull a I'm sorry, if I pull a north card, and then I can have a 1 or a 2. So with north, I can have north 1 or north 2. Same thing with south. I can have south 1, south 2. East, east 1, east 2, and then finally west, west 1, and west 2. So those are, that's another way to do it. Instead of writing a chart, you can write a tree diagram. I kind of like the tree diagram. The only problem with both methods, if you have lots of different options, it's going to take you forever to write them out, correct? So, the important thing that we're going to learn is called the counting method. So if we go back to our first example that we did, where we had 3 tiles in the first bag and 2 tiles in the second bag, if you recall, we had 6 outcomes. And guess what? If I take 3 times 2, I get 6. Okay? In the last example we did with the north, south, east, west, we had 4 cards and 2 tiles. And how many outcomes do we have? 8. So our counting principle, this is called the fundamental counting principle. It states that you can find the total number of outcomes for 2 or more experiments by multiplying the number of outcomes for each separate experiment. So instead of having to do all those different, tree diagrams or writing out a chart, you can simply take the first kind of outcome, which, let's say it's 5 options, and then the second outcome, which could possibly be 3 outcomes. 5 times 3 is 15. That's our fundamental counting principle. Okay, so we have Carrie, who rolls 2 1 to 6 number cubes. So she's rolling the dice, right? How many outcomes are possible? So for the first number cube, or the first die, has 6. The second die has 6. So you take 6 times 6 and you get 36. Now you could do, okay, if I roll a 1, I have 1, 2, 3, 4, 5, 6 for the other die. If I roll a 2 on the first die, I have 1, 2, 3, 4, 5, 6. That would take too long. Okay, it's not horribly long, but you can just use the counting principle to get to your answer of 36 possible outcomes. So pretty easy. Next one, Sammy picks 3 1 through 5 number cubes from a bag. After she picks a number cube, she puts it back into the bag. How many outcomes are possible? Okay, so for the first number cube, there are 5 options. For the second number cube, also 5 outcomes. And then the third cube, also 5 outcomes. You're probably saying, cube, shouldn't there be 6? Well, maybe one of them is blank. I've played games before where you roll the dice and they have blank sides to it, so maybe that's what they're looking at. Now, to use the counting principle, 5 times 5 times 5, or 5 cubed, and we get 125. So she has 125 different outcomes if she uses these 3 number cubes. Okay, so that's it in a nutshell. I'm trying to keep the lessons kind of slightly shorter and then also a little bit easier for you guys as we wrap things up. So your homework is page 416, 4 to 16 all, and you will have a Google Doc to answer those questions on in your homework assignment. All right, have a great day.